Here comes the little shadow and your teacher. Hi. This is the video. Inequality stuff you should have learned in middle school. I'll try to make this brief and as painless as possible for you. So, first thing we're going to start off is, what does an equation mean? Well, what does x equal 3 mean? You're right now shaking your head and saying that is the dumbest question everybody has ever asked me, right? Because x equals 3 means that x literally has to be 3. So if I said find a value of x that makes x equals 3 true, the answer is 3. What does it look like? Well, it looks like that. Because that dot right there is literally the only place in the entire universe of numbers that makes this true. Because if you plug that in, you get the statement 3 equals 3. If this dot was anywhere else, it would not make a true statement. So for an equation, we're going to get the one true statement for this style of equation. Okay, so now we're going to transition into Unit 2, which is inequalities. What does this mean? It means that we want things that are larger than this number. So, what would be an example of something that is greater than this number? 4 would work. 5 would work. 1,000 would work. 4.2 would work. 3.0001 would work. Anything that is larger than 3 would make this statement true. So what we say is, okay, well, if I start putting numbers on those dots, that makes it true, that makes it true, that makes it true. My number line didn't go up to 1,000, but if I put a dot way over there, 3.001 makes it true. And if you kept doing that and kept plotting all of the dots, what you would get is a thick line that goes forever in that direction. Now the question becomes, can I do 3 right there? When I say that, does 3 make that true, or 3 is greater than 3? You should be saying to yourself, no, 3 is not bigger than 3. So I would not include it. The way we show that is with an open circle on the boundary point. This is a graph right here. Sometimes I do it like this, just to show it more clearly with like little squiggles. But this arrow is a picture of all of the things that make this true. All right, you're going to think I'm beating this into the ground, but it's really sometimes hard for people to think about this. What that means is if I put my marker anywhere on that, let's say that that is 5.5. If I take the 5.5 and I stick it in for this value of x, I get this statement. Is 5.5 bigger than 3? Is 5.5 greater than 3? Is 5.5 larger than 3? There's a whole bunch of ways to say that, and the answer would be yes, that is true, because it's there. If I were to pick something here that's not in the shaded area, you would have the statement 1 is bigger than 3. And I'm pretty sure that if anybody told you that $1 was more than $3, you would tell them that that is not true. That is false. So things that are in the shaded arrow part of it make this true. Things that are not make it false. Okay. Very, very similar looking statement, except now it doesn't say x is greater than 3. With the little bar under it, that says x is greater than or equal to 3. So it's all of the same numbers that we had here, except now that dot that we originally said didn't work does work, because this dot makes the statement 3 is greater than or equal to 3. That is now true, because 3 is not greater than 3, but it is equal to 3. So we've combined the two ideas. So the graph of that one is going to be an arrow that represents all of the things that are either bigger than or equal to 3. We represent that by filling in the dot. All right. Switch it around like this. This is now the symbol for less than. This is red. X is less than 3. You could say x is smaller than 3 as well. And so that would fill in the dot, because we're going to include it. And it would be not the things that are on the bigger side. We know that numbers always get bigger as I go this way, and they always get smaller as I go this way. So where are the things that are smaller than 3? It is all of that stuff down to negative infinity all the way down that way. All right, last one. Switch colors here. This is x is smaller than 3, x is less than 3. And again, that would be the same, all of this stuff, because all of these numbers, if I take one of those and randomly put it in there, we get this. Is negative 4 smaller than 3? Yes, so all of these numbers work, but we can't include the boundary value at this point, so we use an open dot to do that. Okay, so my best advice to you on these is stop and think. There's so many students on this stuff who miss half of them because they just flip a coin and they're like, heads I'm gonna go right, tails I'm gonna go left. Heads I'm gonna use an open dot, tails I'm gonna use a closed dot. Just stop and think for like 10 seconds and you will get it right. So if I asked you to graph this, the hard part about this is I've now put the x on the other side, but you can still read it starting with the x. This says that the x is greater than the negative 1. Or you could read it as negative 1 is less than x. If you start with the negative 1, if you start with the x, you would read it as x is greater than 1. Some teachers, me sometimes, I think you can handle it without it, but some teachers say whenever you see the x like this, you should immediately flip this thing around so that the x comes first. When you flip it around, notice how, I know you were told the story about the little fish eating the bigger number. The fish mouth is eating the x. Make sure it's still eating the x. So now it's easier to read sometimes when you say x is bigger than negative 1. X is greater than negative 1. So that would be an open dot on negative 1, shaded that one. Those are all of the things that make this statement true. X's that are bigger than 1. All right, so those are the two hardest things for students. One is, do I use an open or a closed dot? Second is, which way do I go? Do I go that way or do I go that way? Again, stop and think. All right, so try this one. First question, would it be an open dot or a closed dot? You're right. That says fill it in, so we should be using a closed dot on negative 4 on our number line. Second question, should I make the arrow go to the right or should I make the arrow go to the left? You're right. Now, this says that I want m's that are less than or equal to negative 4. The things that are smaller than 4 go this way because those would be numbers like negative 5, negative 6, 7, those are all of the numbers that are smaller than negative 4. So our graph, our arrow would go that way. All right, try this one. Open dot or closed dot? Easy. Doesn't have the bar under it. It means you can't include the boundary number. So you would have an open dot. That open dot would be on 5. Okay, second and harder question. This is one where you have to stop and think. Which way should the arrow go? Did you get it right? These x's need to be smaller than the 5 because the little fish mouth in the story you were told as 4th graders eats the 5 rather than the x, which must mean that the 5 is the bigger number and the x is the smaller number. So we want things that are smaller than 5. So you could say x like this. Notice how when I flipped it, the x, the inequality was eating the 5. It is still eating the 5. This is things that are smaller than 5. So my arrow would go this way. Okay? It's not hard, but it's easy to miss. That's all the problems we got for you. Remember, those two symbols give you the open dot. Those two symbols give you the closed dot. This one always looks to me like some sort of sleeping creature where there's the eye. Anyway, that's what goes on in my brain. All right, have a good day. Hope you learned a lot. Bye.